Big Swift from my calc class last year. They were chatty. Grant. That was the problem. It was Grant 100%. When it wasn't him, it was Sam. I mean, those two just couldn't stop talking. Okay, so what is a function? Good thing we are reviewing this, huh? Okay, so I've heard some different things. I heard a y equals, I heard an f of x. Do those things sound like functions? Yes. So if it's a function, it can be written as y equals. F of x is the same as your y. Key things with functions. Which variable never repeats? See, x never repeats. So a function is like a rule. If I said my function is x plus 3, all right, if you pick a number, 5. 5 plus 3 gives me 8. The next time I put in 5, do I get a different answer? No, you get the same thing every time. That's what it means when it says x doesn't repeat. X gives you, a single x value gives you the same answer every single time. You don't put it in and get 2 different answers out. When we were talking about the graphs, do you remember how we told on a graph? Close. If x doesn't repeat, it passes the vertical line test. The horizontal line test and one-to-one, that's what we talked about when finding inverses. And that was the same thing but with y. Y can't repeat if you're going to find an inverse. Good, you guys are remembering some things. We didn't forget everything over the summer. All right, so we know in this function notation, f of x is the same thing as your y value. All right, if I said f of 3, that means 3 is the x, the whole expression represents the y. So let's practice using a graph. This is the graph of a function. If I asked you to find f of 1, what that means is if x is 1, what is the y value? So I go to my graph. We know x is the horizontal axis. So when the x is 1, what is the y value on this graph? If I ask for f of 5, take a second. Don't say it. See if you can find it. Have an answer? So when f of 5 means x is 5, so we need the y. So we kind of have to estimate there, so negative 3/4, negative 2/3, something like that. So something close to that. Negative 0.7, you know, if you're in the ballpark. All right, domain and range. Do you remember what those words mean?
How far it goes?
Yes. Domain is talking about your x values. So where does x start and stop? We did left to right. For the sake of making it interesting, let's assume these are endpoints here, not arrows. We can also tell that on the graph. It doesn't keep going to the edge of the graph. So we usually did interval notation. Remember, in that brackets mean equal to and parentheses are not equal to. So the first x value my graph touches is 0. And the last x value my graph touches is 7. Okay, so that interval notation says starting at 0 and ending at 7, and everything in between. If it had kept going forever, what did we write? Good, and remember, infinities always have parentheses on them. How do we find the range? Right, you start at the So there's my lowest point, here's my highest point. So it starts at -2 and it ends at 4. Always goes small to large. Part C. What are the local maximums and minimums? What does that mean? Maximums and minimums.
The bottom of the board.
Highest and lowest point. There are different ways you can write those. You could write them as ordered pairs. You could write them in function notation. My highest point is right here. So if I want to give the ordered pair, that would be 2, 4. You could write it like f of 2 equals 4. Or you could say your max is 4 when x equals 2. All those things say the same thing. My local min. So the lowest one on my graph, that one is right here. What do you think? What do you want to call that? 6.25, something like that. And my y is -2. So the actual maximum is the y value, but you do have to use the x to describe where it is. So you could see that written different ways. Remember the key, we talked about local and absolute maxes and mins. On this graph, they are the same. Absolute is the highest or lowest on the entire graph. Local is just higher or lower than surrounding points. So it's possible for a graph to have multiple local maxes or mins. So if I give a graph like this, this is a max and that's a max, this is a local min and that's a local min. But the absolute would just be the single highest or lowest on the whole thing. D, approximate the roots, also known as the zeros of the function. What does that mean? Yes. Roots, zeros, x-intercepts, solutions are all the same thing. Where does this hit the x-axis? So I can see it hits here and here. You only have to give the x value of that. So what do you want to call it? 4.7, 4.6, something like that. And 7, 2 times we hit our axis. Do you guys remember talking about increasing, decreasing constant? So increasing is rising. You give an interval using the x values. Technically, at a point it's not going up or down, but you can really use brackets or parentheses interchangeably on these. So this first section of my graph, what is it doing? Rising or falling? Rising. So I'm going to say starting at 0 until I get to 2. And if you use brackets, that's fine. What happens at 2? Decreasing from 2 until, what do we call that, about 6.2? And then after 6.2, what happens? So we did the union symbol in between. And then it keeps rising until we get to 7, and then the graph ends. Remember doing this stuff? Good. Is there anything that you want me to go over a little more, or do we need another problem like this? Just trying to get back into using our notation, knowing what those different things are asking for. When we get into our calc piece, we are going to do a lot of evaluating functions at the beginning. So I wanted to try a few of these. The first one, why don't you guys give it a shot on your own, see if you remember. If I say f of -2, what am I asking you to do? So that's just asking you to plug in a -2 for all of your x's. -2 squared. We'll practice our no calculator. See what we remember. Nobody even reached for one. Proud of you guys. So -2 squared is 4 times 3 is 12. Minus -2, so plus 2 plus 2. Did you guys get 16? All right. We are going to see expressions like this a lot. So f of a plus 1. We did just a couple in college algebra because I was trying to set you up for this class later on. But it's the same idea. You are replacing your x with an a plus 1. So we're not going to get a number answer here. We are just going to get an expression that has a's in it still. When I say a plus 1 squared, what does that mean? Is there 2 of those? So you have to think about FOILing that out. So we get a squared plus a, so plus 2a plus 1. If I distribute my negative here, so that would be a minus a minus 1 plus 2. If I distribute my 3, and then finally you combine like 2. So you get 3a squared plus 5a plus 4. So you want to see how I got that? So we don't have to just get a number answer on this. Sometimes it's an expression, still has variables in it. So a couple more on here. So see if I do f of 3a squared. Each of my x's gets replaced with a 3a squared. So 3a squared would be 9a to the 4th. So we get 27a to the 4th minus 3a squared plus 2. I want you guys to try D. So, replacing each of my x's with an a plus h. So that means you have the a plus h twice. You do have to follow order of operations. So that exponent before you distribute your 3. So we get a squared plus ah and plus ah would be a 2ah plus h squared. You want to go ahead and distribute that negative, you can. So we get 3a squared plus 6ah plus 3h squared minus a minus h plus 2. How'd you do on that one? Good? Nobody's complaining yet? That's ugly and long? Okay. We will be seeing a lot of these. There's something we did, I told you in college algebra, pre-calc, what it was called, but we were really just worried about like a 3-step process. Do you remember me ever saying the difference quotient? We did this back when we were evaluating functions, and it's actually a really big calc concept. Right now we're going to, since we're working on functions, we'll go ahead and practice evaluating some of these so that when we come to them later on, it's not a big deal for us. So the difference quotient, right now, I would give you the formula on the test for this review unit, like when we actually start doing this over and over again for our calc purposes, then we'll learn it, and we'll learn why it is what it is. But it's a function thing, and so if you remember in last year, what I had you do is step 1, find f of x plus h. And then step 2, I had you take that answer and subtract f of x. And then step 3, I had you take the answer you just got and divide it by h. So we did one piece at a time. We can still take that approach now. It's kind of up to you. As we get more comfortable, some of you might just be able to plug the entire thing into the formula. If you get to the point where you're comfortable with that and you can just set up this big expression, go for it. For now, I will probably break it down into pieces until I feel like everybody's ready to just jump into the whole thing. So we might practice a few of these. I apologize, I really should have left you some room. There might be, I think on the back there's some extra room if you need more space. So we'll do a couple of those. So my difference quotient. We need the f of x plus h. So if I did that, all that means is we go to our equation, we replace the x with x plus h, and we see what we get. So it's negative 4x minus 4h plus 5. Then, step 2, we take the f of x plus h and we subtract f of x. F of x plus h is what we just found, so it's just bringing that answer down. Minus f of x is what we started with. So we carry that down. So if we distribute the negative, positive and negative 4x cancel, positive and negative 5 cancel. So we get negative 4h. So then, f of x plus h minus f of x, that's the answer we just got, the negative 4h. We take that, divide by h, and my final answer is negative 4. So that's my difference quotient. Typically, step 1 is the hardest, the f of x plus h. After that, when you subtract, things are going to drop off. When you divide by h, you'll get rid of some h's. So after the first step, it should be getting nicer as you continue on. All right. Do you guys think you can try B? Let's try that one. This might be the last one we do today. Let's see. You guys did pretty well evaluating those before. So. plus h. When you FOIL that, you get your x squared plus 2xh plus h squared. I'm going to distribute my negative 5. And if you distribute through 2, you get 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 1. You get that for f of x plus h? That's the long one. So it should get better each step from here. Second, we do the f of x plus h minus f of x. So that's the answer we just got, that whole big thing. Minus what we started with. So if you distribute your negative, 2x squared and negative 2x squared cancel, positive and negative 5x cancel, positive and negative 1 cancels. So we just have 4xh plus 2h squared minus 5h. And then the final piece is really the whole thing. It's the answer we just got, all divided by h. So if we carry that answer down, divided by h, that cancels an h out of everything. We get 4x plus 2h minus 1. Okay. Any questions there? I'm going to go ahead and stop